Welcome to a refresher lesson for rational functions, properties, and operations. This video corresponds to the examples on a worksheet packet that can be found at my Teachers Pay Teachers store. In this video, I will explain the skills and steps necessary to complete all of the examples on the worksheet. Please feel free to skip around to engage in the concepts with which you would like some help. So let's start by talking about how to simplify rational expressions. If we have an expression such as x squared minus 3x over x squared minus x minus 6, one thing to realize is that rational expressions are simply a polynomial in a numerator over a polynomial in a denominator. And so based on previous lessons and units that maybe you've found in my YouTube or at my Teachers Pay Teachers store, we should know how to factor these polynomials. So when we are simplifying, one of the first things we need to do is factor the numerator and the denominators as much as possible. So in this case, if we take our x squared minus 3x in the numerator, we would factor that into an x times x minus 3. And then if we have x squared minus x minus 6 in the denominator, that would factor into x minus 3 times x plus 2. The reason we do this is just like with a fraction. If I have a fraction like 6/8, let's say, we can simplify this fraction or this very simple form of rational expression by dividing the numerator and the denominator by a common factor. So in 6, we have the common factor of 2. In 8, we also have a common factor of 2. So if we cancel out or divide each of those by that 2, we simplify to a fraction of 3/4. Same idea with rational expressions. In order to simplify, we first need to factor the numerator and the denominator, excuse me, in order to see if there are any common factors. If there are, then we need to cancel those common factors out in order to simplify. So in this case, we can see that x minus 3 is a common factor in both our numerator and our denominator. So by canceling those out, we are then left with just x in the numerator and an x plus 2 in the denominator. And that is our simplified version of the original expression that we started with. Now, if we start looking at operations with rational expressions, we constantly want to think back to what we already know, which is how do we do these operations with fractions? And that will give us a good guide as to how to do them with rational expressions. So for adding and subtracting, for example, if I had 3/4 plus 5/8, one of the things we know is that we need to get a least common denominator, which is just the least common multiple of the denominators. The least common denominator for 4 and 8 would be 8. So applying that logic to our rational expressions, we also need to find the least common denominator for our two denominators here, our x squared minus x minus 20 and our x squared minus 25. In order to do that, we need to again have factors. but we only are really concerned about factors in the denominators. So x squared minus x minus 20 will factor into x minus 5 and x plus 4. Our x squared minus 25 is a difference of squares, and that will factor into x plus 5 and x minus 5. Now, if you think about with numbers, if you remember, we can take numbers and break them down into their prime factors. So 4 would be 2 times 2, and 8 would be 2 times 4, break down the 4 more. So we would have a 2 squared compared to a 2 cubed. And when we're trying to find the least common multiple of these two, we choose between the two denominators how many of each factor we're going to use. And we choose the one that uses it the most. So here we have a choice between using 2 twice or using 2 3 times. So we would choose the 3 times to get our 8. Okay, same logic applies with rational expressions. We're going to look at the factors being used. We are going to choose from one denominator or the other, and we're going to choose the one that uses the factor most. If the factor is being used the same number of times, then we choose one or the other, not both. So in this case, we can see that we have an x plus 4 here that is only in the first denominator. We have an x plus 5 here that is only in the second denominator. And then we have an x minus 5, which is in both denominators, but it's only being used once in both denominators. So we will just choose one of them. It doesn't matter which one, but only one. So our least common denominator for these two rational expressions is going to be the x plus 4, the x plus 5, and just one x minus 5. Okay, so now we're going to rewrite our original expression into an equivalent expression with this least common denominator. So we need one fraction that has x plus 4, x plus 5, and x minus 5. And then we're going to subtract our second fraction, which also needs x plus 4, x plus 5, and x minus 5 as its denominator. Now, in order to write equivalent fractions or expressions, whatever we multiply by the bottom, the denominator, in order to create our least common denominator, we also have to multiply to the numerator. So in this case, we can see that we have the x plus 4 here. Okay, that's a match. And we already have the x minus 5 here. What we're missing is the x plus 5. So that must have been what we multiplied by. So the 3 that was already there will now need to be multiplied by this x plus 5 that we were missing in order to keep that first fraction equivalent. Then we look at the same thing in the second fraction. We have the x plus 5 this time that matches. We have the x minus 5 that already matches, and it's the x plus 4 that we are missing. So we must have had to multiply both the numerator, which was originally x, by that x plus 4, as well as the denominator by that x plus 4 in order to keep it equivalent. Okay, Now we can go ahead and simplify our numerators and combine them together all over this LCD of x plus 4, x plus 5, and x minus 5. Okay, so if I distribute the 3 here, I will get a 3x plus 15. Notice this is minus, and so I highly recommend that you change this into plus and throw a negative up here with that x. And then when you distribute, make sure you are distributing a negative x to both of your terms. So we'll get a negative x squared minus a 4x. And then we'll simplify our numerator. So we have a negative x squared. We have a 3x and a negative 4x, which will give us negative x. And then we have the 15 all over x plus 4, x plus 5, and x minus 5. Lastly, I would recommend that you check just to see, does this numerator look like something that can be factored? Because if it can, there may be a common factor that we need to cancel out. In this case, it cannot be. So if we're looking at whether this can be factored or not, we're saying no in this case. And so this is our final answer. We do not need to expand the denominator. Just leave it in factored form. So negative x squared minus x plus 15 over x plus 4 times x plus 5 times x minus 5 is our final answer. Now, for multiplying rational expressions, again, let's think back to multiplying fractions. If we're going to multiply fractions, let's say we want 9/16 times 4/5. One of the tricks that we've done in the past is that we can cross cancel any common factors. So here we would see that we have a 4. 16 also has a factor of 4. Divide 16 by 4, we get 4. Divide 4 by 4, we get 1. 9 and 5 do not have any common factors, so now we can do our multiplying across. 9 times 1 would be 9, and 4 times 5 would be 20. And by doing the cross canceling, the result that we get should already be simplified. So again, same idea with multiplying rational expressions. We want to be able to cross cancel or potentially even cancel within the same expression. And to do that, we have to know what the factors are. We cannot, please hear me, we cannot cancel terms. So I cannot look at this and say, oh, there's an x squared and there's an x squared. I'll just cancel those out. Those are terms. Those are not factors. So you have to go through the process of actually factoring in order to be able to see what can be canceled out. So in our first numerator, we have a common x in both terms, which leaves us with 2x minus 1. In our first denominator, we have x squared minus 4x minus 5, which factors into x minus 5 times x plus 1. In our second numerator, our x squared plus 6x plus 5 will factor into x plus 1 times x plus 5. And in our second denominator, the 2x squared plus 5x minus 3 can be factored into 2x, minus 1. There we go. Times an x plus 3. Okay, So now that we have everything in factored form, now we can look for common factors that are either in the same rational expression, so in the numerator and the denominator of the same expression, which can be canceled, or going across numerators and denominators of different rational expressions. So here I can see I have a 2x minus 1, which can cancel with the 2x minus 1 in the second denominator. I also see here in the first denominator, I have an x plus 1, which I can cancel with an x plus 1 in the second numerator. And then that seems to be it. Those are really the only matching factors. Again, make sure that it is one factor in a numerator and one factor in a denominator that you are canceling out. Having the same factor both be in a numerator or both be in a denominator does not allow you to cancel. All right, so now we're ready to multiply across our numerators, which means I have an x times an x plus 5. And in our denominators, we have an x minus 5 times an x plus 3. Always a good idea to just look one more time to be certain that you don't have any common factors left. And then in the classes I have taught, I allowed this to be our final answer. You'll need to go with what your teacher's expectations are as to whether she or he would like this numerator to be expanded. If you wrote x squared plus 5x over x minus 5 times x plus 3, that would also be correct. I don't find that to be necessary, so I don't usually teach my students to do that, but you will need to follow the expectations of your teacher. All right, what about division? Well, again, think about what we do with division of fractions. If I have a fraction like 12 over 13, and we're going to divide that by 16 over 21, what we usually do is actually change the division into multiplication. So our first fraction stays the same, 12 over 13, and then we multiply and invert. Then we're just following multiplication rules. We look for common factors like a 4, divide those out, and then multiply across. Okay, so again, the same is going to be our guide for dividing rational expressions. It doesn't really matter whether you factor first and then change to multiplication or multiply first and then factor. Just make sure you do both things before you start canceling. Now notice here, in our first numerator, actually, let me back up a step. I'm going to go ahead and flip first. So we're going to make this x cubed plus 8 over x squared plus 3x minus 4. And then we're going to change this to multiplying by x squared plus 5x plus 4 over x squared plus x minus 2. Now let's talk about factoring. So you'll notice here, in the first numerator, I have a sum of cubes. There is a pattern to factoring the sum or difference of cube numbers. And the pattern looks like this. If I have some number cubed, and in this case, we'll say plus some number cubed, that can be factored into taking those numbers, A and B, whatever it is that we're being cubed to give you this. And then you have the A squared, the A times B, and the B squared. Okay, now let me actually go back here for a second. Let's erase this. Regardless of whether you have a cubed plus b cubed or a cubed minus b cubed, this is your first step. You will have a and b in the first parentheses as a binomial. You'll have a squared, ab, and b squared as the terms in the second parentheses, which is a trinomial. The difference between the sum and the difference of cubes is the signs that you put between them. And you can remember what signs to use with the word SOAP. And in the word SOAP, the S stands for same, which means whatever sign was here is the sign that goes here. So in this case, if it's plus, we put plus in between. If it had been subtract, we would put subtract in between. The O stands for opposite. So that is the opposite sign of what we had in the problem. So in this case, since it was addition between our two cubes, then we're going to go with the opposite sign here for subtraction. And then the A and the P together stand for always positive. So the last term in your trinomial will always be positive. It will always be plus. So our x cubed plus 8 means that our A that was getting cubed is x, and our B that was getting cubed was 2. So we'll have x and 2 in the first parentheses. We'll have x squared, 2x, and 2 squared, which will be 4 in the second parentheses. Since this is addition, we go same, opposite, always positive. And that is the factored form of x cubed plus 8. All right, continuing to our first denominator, x squared plus 3x minus 4 is going to become x plus 4 times x minus 1. X squared plus 5x plus 4 is going to become x plus 4, x plus 1 in factored form, and x squared plus x minus 2 will be x plus 2 times x minus 1 in factored form. Now you're just back to what we were doing with multiplication, just like we said with numbers. Now you look for common factors that can be canceled. So I have an x plus 2 in the first numerator and second denominator. I have an x plus 4 in the first denominator and second numerator. I do have matching x minus 1s, but they're both in denominators, so they cannot be canceled. And so I think that's it. I think that's all we can cancel out. So our final answer is going to be this x plus 1, and I'm going to put it first since it's a binomial, times this remaining x squared minus 2x plus 4. And in the denominator, we've got x minus 1 remaining in both of them. So I'm going to write that as x minus 1 quantity squared. All right, last type of problem is simplifying complex fractions, which is when you have fractions or rational exponents inside of another fraction structure. Okay, there's two ways you can go about this. And so I'm going to show you both options, and you can choose the one that makes the most sense and feels most comfortable to you. So in option 1, we are going to take any numerator or denominator that has more than one term being added or subtracted. and we're going to combine those terms together. So in this case, we're going to take this numerator, which has the 3 over x plus 1 plus 2 over x minus 1, and combine that into a single fraction. And so we know, I'm just going to do this over to the side for a minute, 3 over x plus 1 plus 2 over x minus 1. Based on the example we had a few minutes ago, we need to find the LCD. X plus 1 and x minus 1, there's no commonality there, so we will need both of them. And so this needed to be multiplied by x minus 1 to get our LCD. This had to be multiplied by x plus 1 to get our LCD. And so 3x minus 3 plus 2x plus 2 over x plus 1, x minus 1. Combine our numerator and we get a 5x minus 1 over x plus 1, x minus 1. So we are now going to use that as our first numerator. And all of that is still over x minus 1 over x plus 1. Okay. Now, step 2 is to actually think of this as a division problem. We know that this fraction bar means the same as divide by. So we're going to think of this as 5x minus 1 over x plus 1, x minus 1 being divided by the x minus 1 over x plus 1. And now we're going to work the rest of this as a division problem, which we just said means taking our first rational expression and multiplying by the inverted second rational expression. Now we can look for any common factors, which are x plus 1 is common in a numerator and a denominator, so we can cancel that out. And then we will multiply our numerators and denominators together. So I'm left with a 5x minus 1 in the numerator, and I'm left with 2x minus 1s in the denominator that will get multiplied together to give us x minus 1 squared. So that's one way that you can go about this. Another option, using the same problem, is to actually look at all of our denominators. So any denominator in the numerator or the denominator, and decide what is the LCD using all of those denominators. Now, in this case, our LCD would be an x plus 1 and an x minus 1. Okay, and so what I'm going to do is I'm going to take my complex fraction and I'm going to multiply both the top and the bottom by this LCD. Okay, now keep in mind with the numerator in this case, because this was two terms being added together, when I multiply, this whole thing gets distributed to both of these terms. So when I take the x plus 1, x minus 1 times the 3 over x plus 1, the x plus 1s cancel out. And so I'm left with the 3 times the x minus 1. When I take x plus 1, x minus 1 and distribute it to the 2 over x minus 1, Now the x minus 1's cancel out, and I'm left with 2 times x plus 1. Now in the denominator, it's just a single term being multiplied. So all I have to really do here is just cancel the x plus 1's, and I'm left with that x minus 1 times itself, which is going to be squared. And now I think you can see we end up with the same result we got in the previous option. We distribute the 3 and the 2, and we simplify to get the 5x minus 1 in the numerator over the x minus 1 quantity squared. Personally, I think this is an easier way to do the problem if you're comfortable with finding LCDs. But both options work, and so whichever one makes more sense to you and feels more comfortable to you is totally fine. Just make sure you show your work on how you're approaching it so your teacher can follow your thinking. All right. I hope you found this helpful. If you would like to see other concepts that you need to refresh or review, please check out my Gordon Global Math page on YouTube. Videos covering Algebra 2 and pre-calculus concepts will be added throughout the spring of 2025. Thanks for watching.